with Xerion to develop a product called SmartCat. It's RFID capital asset tracking. My name is Tyler Kern. I am in charge of the business development side. I work with all the implementation of the product, focusing on the software, hardware, and the RFID tags. It's a lot of custom work.
I'm Suraj Prakash, and I'm the product manager for SmartCat. I've been with William Frick for 5 years now, and instrumental in the development of the product, and now I kind of take care of the platform. Kind of what William Frick's version of Ben ran into.
Less videos.
And more Indian.
All right, so who is William Frick? Frick has been around since 1975, and we focused on the development of outdoor, durable, harsh environment identification products, signs and labels. In layman's terms, this is equated to mostly asset management. We've been tagging things. Our business model is based around a value-added sales approach. We want to work with customers to figure out exactly what kind of identification needs they have, and then we go and design and manufacture usually a custom product for them. In recent years, or more recent years, the 80s, identification products moved into a need to tie them to electronic systems, and that's where barcodes became a thing. So most of our products incorporated barcodes. Over time, that has transcended into what is now RFID, radio frequency identification. This has opened up a lot of opportunity, and as far as electronic systems are concerned, it creates a way to really integrate systems and collect the kind of data you need. So what are we going to talk about today? We're going to give you a little brief overview on the tech side of RFID, how it works, what it is. Then we'll talk about SmartCat and how that uses RFID and the iPhone Builder platform to really create a really cool solution. And we'll go into some use cases to help explain it. I'll leave Suraj with that.
So for a few minutes, we're going to go through like an education session. Sorry, I know everyone's hungry, but what is RFID? RFID stands for radio frequency identification, and I'm sure everyone here has kind of crossed paths with RFID. It basically originated in the World War II era when it was used to identify enemy or foe friend planes, and kind of evolved over time in terms of, as is with everything, ended up to Walmart. And basically Walmart started to mandate RFID in about early 2000s, mandate RFID into sort of tracking pallets and boxes of things that are coming in. So if you imagine like a box full of toothpastes, you can scan a barcode one at a time, and that's well and good because that's how a lot of retail stores do it right now. But Walmart wanted that box or pallet of toothpaste to walk through a door, and imagine sort of RFID, these are like sort of fixed readers sitting on top of the door, scan through the box of thousands of toothpaste within seconds. That's kind of the power of RFID, and that's where RFID came to be. Barcode versus RFID, the way I like to think of it is RFID is barcodes on steroids. And so think of everything that a barcode can do. RFID can just do it a little more efficiently. So you can read multiple things at a time. You have the ability to read data, but then also rewrite the data. So you're not dependent on the print itself. There's a chip within the tag which holds the data. You also have a lot more sort of room for more data. QR codes, and there's PDFs and things which are different kinds of barcodes out there that do hold a lot of data, but then you come into sort of placements of what kind of data. Is it dynamic data? So airlines, for example, would actually append maintenance records onto RFID tags, and that's something that my colleague Brent Howell will discuss later. The broad categories of RFID are active and passive. So think of active like your tolling solution, so your Easy Pass or iPass. When your car drives through the toll portals, your Easy Pass, which is hanging off the windshield, mine's broken in the dashboard, but it basically scans that. And the reason it scans it is because the pass actually has a battery in it, which powers it to be able to be read, from a greater distance and a much more strength and accuracy. Passive RFID, on the other hand, are longer-term RFID tags that do not have batteries. Think of your reader turning on the tag, sucking in the data, and then showing you the data on the reader side. So the tags can last for years. Think of your hotel pass, hotel room access card. So in terms of frequencies, there are 3 broad frequencies. There's the low frequency, which is LF, high frequency, which is also referred to as NFC, which is called near field communication. And then there's ultra high frequency. We're going to sort of concentrate on the near field communication and ultra high frequency for the next couple of minutes. Near field communication, I'm sure you know about the Apple Pay or the Android Samsung Pay. You can basically tap an object that is NFC enabled and scan the data from it or transfer data to it. That's near field communication. It's one thing at a time, but it's high data accuracy. In Europe, it's also used for the subway system. So you can basically have an NFC card, which is a secure card that scans you into whatever train you want to use or tube you want to use. Ultra high frequency, real quick, is the kind of opposite of that, where you can read multiple tags at a time, and it's reading things really fast. It's more for inventory scenarios, and it really serves its purpose when things are far. So think of like a pull top transformer that I can scan from down here, or things are there are a lot of things that you want to scan at once. Okay, so real quick here, how is RFID being used before we jump into sort of smart cat use cases? For some of our customers, marathon race timing, so bibs actually have RFID tags right behind it, and when you run through the portal or the finish line, there are actually mats down below that have RFID tags within them, and that's how they record your timing. There's also high security and also barrel tracking sort of solutions in the alcohol industry. So we're working with someone that Tyler really enjoys working with. It's a distillery, and they do barrel tracking. So the barrels actually have what we call a dual frequency tag. So it is NFC enabled and it is UHF enabled. And the reason is that they're using both for their pros. So when they want to do an inventory, they walk down the cave and they scan all these tags, the UHF part of the tags. And then when they want to identify a barrel and update they're topping off the barrel, or if they're recording the temperature data or whatever it is, they want to identify an individual barrel, that's when they use NFC. There's pallet tracking. Oil and gas is something like, I think Tyler mentioned earlier, we've worked with for about 40, 45 years. So we're really pushing RFID in those solutions as well for tracking pipes. So I'm going to let Tyler take over and discuss his first use case and SmartCat actually.
So what is SmartCat?
You know what? I messed up. Sorry, I thought this was later. I'm going to talk still. So there's SmartCat XR. So SmartCat started a while back, and this was about three and a half years ago. Brainchild of Jeff Brandt, who's the president of our company. I do take some credit for it too, but basically what we started off with was a handheld reader. And the idea was to give the mom and pop shops and also the bigger companies that want to evaluate the technology, because RFID itself can run a very expensive infrastructure implementation, up to $500,000, $600,000. So this was giving them custom forms, custom data, and the ability to catch whatever data they want to with RFID. Sound familiar? Yeah. A few sort of years ago, like Ryan mentioned, I was at Esri UC, and that's where I met Ben, and Ben was there showing the iForm demo, which was really cool. I walk up and I see, oh my God, like this is everything that we want to do, but it's not on an obsolete Windows environment. It's actually on an iOS and Android environment, and it's really smart. At the time, for me, looking at a simple dynamic drop-down menu was just really cool. And Ben, with his explanations, got into all the nitty-gritties, and very soon I realized, and Jeff Brandt realized, that here's a partnership that can actually work, where we really take care of the data collection engine from Xerion's standpoint. So we make use of their really vast sort of platform that they have set up and add RFID to that. Because really our value is in the RFID space. That's where we have expertise. Like Ryan mentioned earlier, that's our sort of we're the champions in that area from our perspective at least. And so that's where we started working with Xerion about 3 years ago, or 2.5 years ago, and developed a version over time. It took a while, but we got to a point where we developed an app together called Smart Capture, and that's where Tyler comes in.
So during the development of that app, I was brought in to learn everything about it and to figure out exactly how we're going to sell this thing and how it's going to work. SmartCat has become quite the solution. It's based on 2 different apps. One app you guys are very familiar with. It's a white label version of your iPhone builder with a little extra swag. We made it red. It's better. It helps us collect all the data. The second app was the development piece. We needed a way to capture all the RFID data and get it into that SmartCat Forms app. Capture became that tool. It has 3 primary functions. It collects NFC information, as Suraj mentioned. You tap tags, and it transfers the information in a very secure way. It has UHF information, so it'll go and collect tags that are over distance. You can also, the most critical part, collect multiple tags at once. It completely changes the game on how you can collect asset information. The third one is barcode. We needed a way for people who were going and doing testing with RFID to also incorporate their old systems. So a barcode reader was necessary. This leads us to the full SmartCat solution. This solution is kind of a trilogy. It's a combination of RFID tags, customized workflows, so we work with the customer to figure out exactly how to build those forms to best collect data, and the hardware necessary. So one of the major points here, and I made a note about this so I don't screw this up, it is by pairing the tags with the workflows, and these tags are fully customizable, you can essentially customize a very versatile and scalable data solution that allows you to identify and automate the most granular tasks. So things that before were very difficult to go and automate, very minute tasks that people needed to collect data on, they're now able to do it with a technology that had a very significant capital investment. We're offering a solution that is not. It's easy to get into, and it allows customers to start right away and scale their way up into a big solution. So, moving forward, I'm going to talk about how we use this. Our first use case is electric utility pole tracking. We work with a utility pole distributor. One of the main things they need to do is keep a distinct inventory of poles at specific locations across the country in case natural disasters occur, something happens, they need to quickly go and repair a pole and get things taken care of so their system is up and running again. These poles come in all different kinds of shapes, sizes, materials, and they have a hard time keeping track of those. How do you go and maintain a specific inventory of poles at a remote location, and you just can't do it. It's a process that takes hours, and it takes a lot of manpower. So what we did was we first focused on the tag. We found a very rugged on-metal tag for these metal poles. This tag can be scanned from a long distance, and it's a UHF tag, so it allows multiple tags to be read at once. What we did was we encoded each tag with a very specific memory that recognizes the classification of the poles, as well as an ID number that ties it back into their ERP systems. So when you go and scan the poles, you are able to relate it to all the data systems that they're part of. Diving into the workflow after this, we built a form that works exactly as the user needed to work on site. So they needed to record a GPS location, which they tied to a GIS location. They needed to also select which site location they were at. This site location triggered a lookup, as you guys are very familiar with, that pulled in last inventory scan data. So all this data that they pull in is from the last time that they ran a scan, meaning now when they run a new scan, they're able to run a big comparison and find out what has changed. That triggers the RFID scan, so they'll walk around their yard and scan poles. And I'll give you a quick demo of that. So I have placed RFID tags under all of your seats. You guys can play around with them. Essentially what these guys are doing on site, they're going to go and they're going to scan all of these tags. And by collecting all of the tags on site, it populates onto the device. In their case, they're selecting all of their tags, and they're going to confirm that. All that information is brought back into the form builder, or the forms, and their inventory is done. They didn't have to record anything by hand. They didn't have to remember it in their head, write it down. They didn't have any incorrect data classification of which type of pole it is, how long it is, etc. It's all automated. So after they go and run that scan, they are able, one of their main needs is to be able to see as a user what happened. So because we were pulling that last inventory scan data in, and we have now ran a new inventory scan, we can run a comparison on site so that user can see what's going on, make any necessary changes he needs to make, or call anybody he needs to call and get things taken care of. This basically runs as a page-level JavaScript PHP script function that we built, and returns, number of parts scanned, all the necessary information, so these guys can take care of their inventory. So what did this give us? A job that used to take 1.5, 2 hours doing things by hand now takes a matter of minutes. The biggest thing is data integrity. They are not trying to remember what poles they have on site. They're not trying to remember classifications. All their data is secure, it's verifiable, and it's accurate. They get a real-time inventory update on the device, and they get a real-time inventory update in their back-end systems. It synchronizes with their ERP database, and they're able to shift inventory around as needed. They also remove manual input of data, kind of iPhone Village core functions. Unless you would talk about another use case.
Oh, cool. So the clicker's working. So over the next couple of minutes, we're going to talk about restrooms. So sorry if you need to take a restroom break. Over time, we've also identified a really strong use case for sanitation and so janitorial teams, and giving them the ability to be more accountable with their staff. So two main industries that we're working within are healthcare and hospitality for this application. So if you think of ICUs, or if you think of patient rooms, at the same time think of kitchens or even drink stations at a restaurant, they need to be cleaned, and not just cleaned, but cleaned to the specific guidelines, specific chemicals and stuff. So before we dive into that, just want to kind of iterate a few problems that our customers were noticing. So first, they were seeing that their teams, even though they were trained at the front end, there was no real way to keep them updated with the training guidelines. And so because these training guidelines are so specific to rooms, especially in a hospital scenario where you have an ICU or you have an OR or you have an LDR, and these are all rooms that have specific ways that they need to be cleaned, it was difficult for them to make sure that these training guidelines were updated constantly and the people were actually following it. The other part was, a lot of these rooms need a cure time. So people need to wait for 10 minutes after the rooms have been cleaned and disinfected before a new patient walks in or before anyone does anything within those rooms. And that was difficult for them to maintain. The other part is, high churn rate. So if you look at a restaurant scenario, if you think of someone like a Pizza Hut, they're going to have constantly new employees joining the team. And when that happens, you're going to find checklists like those where, someone signs for 2 hours and then just like draws a line all the way down as if that means something to someone and walks out. We've all been to restrooms where they're just nauseatingly disgusting and ruins the experience. And that kind of brings us to the next point, which is ruining customer experience. So it was funny because one of the restaurants that we were working with, when we were setting up a demo for them, I wanted to make sure that I had a very nasty looking picture, and I Googled it, and the first couple of pictures that came up were from their restaurant and were submitted by a customer. So the big issue there is that, hey, not only are my customers, finding my restrooms disgusting, they're also kind of going online and yelping about it or blogging about it. The other part is, is the supervisor able to actually be sure that this was cleaned and when it was cleaned? And talking about the cure time, and a restroom, when you walk in and you see the checklist, it's one thing, because again, it's paper form, and we all know the negatives of paper form. That's why we're here. But it's also having the ability to know the positive, right? So by that I mean, if you know that something has been cleaned very positively, you're sure that it's been cleaned, there's a positive effect to that. And that's the visibility that a lot of our customers said, hey, we want this, and this is something we don't have right now. So we bring in what we call an e-paper NFC tag. And so I'm going to pass this around. Unfortunately, I only have one of these right now. And if you don't mind passing it along. The concept is that it's an NFC tag. So again, near field communication. So it's activated by your phone, and it's got an e-paper technology, and think of Kindle, that changes the message when you scan it. So now think of this on a wall instead of a checklist, where this cannot be, you can't really change the message on there unless you have SmartCap forms, aka iPhone, and you have SmartCap, which basically enables you to scan this. So let's go through the use case, right? They have a tag on the wall. The person who is in charge of cleaning this room walks up to the tag, scans the tag with the SmartCap phone. And I actually have a quick video here. So. Okay. So in this video, I take the phone, I tap the device, and it changes the message on the device. And similarly, when I go through, let's go back here. Everyone saw that?
Yeah.
Okay. So when I scan the device, it changes the message. So it starts with cleaning in progress, so do not enter. And this is customizable, right? So you can change the message on here. So for a hospital scenario, please wait for the cure time to be up, or please wait for 10 additional minutes, or whatever. And then I get, of course, a very specific checklist. So one of the things with RFID tags and with automated data capture is that you're getting accurate data. So the data within the chip is a specific ID. So think of an ICU that requires certain chemicals to clean the area with, certain disinfectants. And then think of the cafeteria in the same hospital that requires other disinfectants to be used. With the accurate scans, you're getting actual guidelines that are specific to that room. This was surprisingly a huge value for the customer. The other thing is, once I finish, I scan again and I update the message on the tag itself. So now that tag message, not only does it say last clean, but it also says manager on duty or employee who cleaned. And now you've actually connected the the process to an accountable sort of an invisible process. So you've made this positive impression on the customer where I have the ability to see who was the person who cleaned it, who was the manager on staff, and this isn't like paper form again, which can be sort of faked. And finally, you have from the standpoint of the customer, kind of just reiterating what I just said, which is basically the ability to, have not just names and not just the people, but the actual positive influence of our experience of walking into a clean environment. And again, that is, intangible. We can't really discuss that through slides or, a form, digital form. So, kind of tying it all up with strengths of SmartCat, and really quickly going to go through this, but RFID, right? RFID, hopefully we've kind of explained how RFID is different from barcode. Not saying that barcode, obviously barcode has its strengths, and one of the big strengths of barcode is that you have this very easy sort of implementation that now, because it's so wide, to apply. So for example, if you wanted to go into a Walmart now and you wanted to change the items that have the UPC code, UPC is the item code in the back of the product itself, it's going to be a lot longer of a process to make that RFID. But where you can make it RFID is for Walmart to be able to track those pallets. Instead of those individual items, I'm tracking pallets and I'm equating that to value. There's also reading without line of sight. So not needing the print is a great value to our outdoor applications. So on a pipeline that's going to be in the Arizona heat for years, I'm not reliant on the print to last. Connecting it to GIS, so one of the big reasons that even we partner with Esri is because there's value in micro data. So you have multiple assets on a pole at one location. How do I identify the differences between the two pole top transformers on the same pole as opposed to the signs and as opposed to the lights? That's kind of where RFID comes into play. GIS is beautiful for mapping. It's great for identifying assets and their locations. RFID really just boosts that ability to identify at that location. Data accuracy, so going back to that the data is within a chip. Our airline partners like to password protect their data. They also like to enable security in terms of destruction. So if someone destroys the tag's data would change. And those are things that you can do with RFID which weren't really conceivable with barcode. Lastly, the tags and the applications that we work with. So there are a few here, but our the way we work with RFID tags is basically identifying what the problem is and then kind of constructing a unique tag for that problem. And so the sample packs that you might have are basically showing those different tags in those different applications. And then just kind of this slide. I don't know why I put this slide again, but just to remind the fact that our workflow is three-pronged. So there's the tag, there's the form, and then there's the workload. So finally, this is us. Thank you for listening to us, and really wanted to thank Ryan, his team, or Yun Hong, Ben. They've been great. We don't have their pictures up here, but they've been great to work with, and it's only been a pleasure. And we hope for a strong future. So, any questions?
Okay. Real quick, some of the interesting things is the customization of the tags. And I know Tyler and I have had a handful of conversations, especially in, say, the oil and gas space where it might be. I think it's helpful to understand some of the complexities in terms of what goes into the reading. Taking into consideration, our applications and our devices are going into some really, remote parts of the world. I don't know, you mentioned underground and everything else. What does that engineering side kind of look like in terms of creating those kinds of solutions? Or rallying off some of the obscurities of the RFID tags?
That's a great question. It's we have probably thousands and thousands of tag designs that we've created over the years. At least he has.
Not thousands, but yeah, a
It
lot.
sounds better when I say thousands. Anyway, like most tags are specifically designed for that exact application. If it's an oil pipeline, we want to design something that's going to last 30 years of inspections. If it's underground, it needs to read really fine. An RF signal can only read so well through moisture and materials. So there's a lot that goes into it, and that's why we do have this engineering team to speak more towards that.
And then, I mean, as a company, I know you guys probably don't think stickers are glamorous, but we, as a company, are really proud of labels. So every application requires its own sort of construction, and there's parts of materials, so like temperatures. So what are the extreme temperatures you're going at? What temperatures are you applying the tags at? Hey, what is the length of the data that you want to read? And by the way, what reader are you using? These are important questions for us to understand what is the tag. And then also from our standpoint, we encode the data into the tag. We also have, SmartTag has the ability to let you encode the data, but from an efficiency standpoint, if you're doing 100,000 tags, then you don't want to sit and encode those 100,000 tags. So we, in our manufacturing processes, actually encode those tags. Does that kind of into what you were asking?
Yeah, you mentioned a lot of your processes start with data collection. They really start with how you collect that data. And that's what we focus on is how that data is created. And that starts with tagging assets and all the labels and whatever you're relating the data to.
Just a little feedback. I mean, it's pretty amazing that you can just hold the reader up in the air and grab everything at once. I mean, I'm sure Al, you can attest to this. How much time have we spent trying to go through and zap 30, 40 barcodes? And I mean, it's exciting, but a little depressing that they're able to do it in 2 seconds or so, right?
Well, no, I think that's really interesting, and clearly you spend a lot of time trying to make sure that everything should be in a trolley, should be there, and counting, recounting, packing, and we've always had the idea, and the panacea would be just push the trolley through a reader and have it tell you what's not there or what is there. So that's would be wonderful. We just haven't never gotten right now.
Any questions? Thanks, guys.
Thank you.